Dear members of the Dissertation Council and everybody present, we're starting our session of the Dissertation Council, and I would like to open formally this Dissertation Council dedicated to the defense of the dissertation by Petrov Alexander Nikolayevich, seeking an academic degree of Doctor of Physics and Mathematics in the Specialty 01.04.12, Theoretical Physics. And the topic is theoretical study of diatomic molecules to search for the electric dipole moment of electron. And let me start and open formally this Dissertation Council. I would like to introduce myself. I, Leonty Lobzovsky, Doctor of Physico-Mathematical Sciences, Professor of the Department of Quantum Mechanics, St. Petersburg University. And I'm appointed chairman of this Dissertation Council. And by the Act of St. Petersburg, then Andrei Vladislavovich Tolarov, Doctor of Physics and Mathematics, the head of the Department of Laser Chemistry of Moscow State University, named after Mikhail Lomonosov. Next, to the left of me, is Yuri Mikhailovich Chuvilsky, Doctor of Physical and Mathematical Sciences, Professor, leading research fellow of the Research Institute of Nuclear Physics, named after Skobelnitsyn, Moscow State University, named after Lomonosov. And to the right of Andrei Vladislavovich is Professor Yerdokin, Vladimir Anatolovich, Doctor of Physical and Mathematical Sciences, a lead researcher of the Department of the Center of Prospective Research, St. Petersburg Polytechnic University, named after Peter the Great. And on Skype with us is Dmitry Budker, PhD, Helmholtz Institute, Mainz University, named after Johann Gutenberg, Germany. Dear colleagues, dear ladies and gentlemen, I have some problems with reading the text. I can only read with the help of this electronics, and so this these difficulties are more obvious today. I would like to ask my colleague to be my substitute, to be my deputy, and Professor Tilnov, professor of our department, St. Petersburg University. I'll be following very closely the progress of the session, and I will again take part in the session when a decision needs to be taken, and I would like to give the floor to Professor Tilinov. Do you have any objections? Well, let me now give the reins to Dmitry Alexandrovich, and would like to help Leonid Nakhimовich with reading the agenda, and now I would like to introduce the following documentation that we received. Well, I would like to first point your attention to the federal law dated 23rd August 1996 on science and state scientific and technological policy. St. Petersburg University, according to it, received the right to issue degrees, academic degrees, independently, and this act will be then sorry, what's going on? According to this act, a session of the Dissertation Council is legitimate if not less than 2/3 of the membership, established membership, take part in it, but not less than 3 people. Our dissertation council consists of 6 people. One is in remote control mode on Skype, and everybody is here, and so the quorum is there. Leonid Nakhimовich, yes. I would like to I suggest the following agenda for this session of the Dissertation Council, which will not exceed 3 hours. And so now I would like to hear the agenda again. The first item is a short presentation of the chairman of the about the paperwork presented by the candidate, and the satisfaction of this paperwork to the standards of St. Petersburg University. And the second item is a short presentation of the dissertation, not more than 20 minutes. Third, questions on the presentation of not more than 2 minutes per question, and then answers of the candidate. The fourth item, presentations of all members of the station with their views, and probably questions or suggestions to the dissertation author, of not more than 10 minutes per speaker. And then the fifth is the presentation of the chairman with his review. The sixth is the questions of the candidate to answer questions of the dissertation council members, more than 15 minutes, an open discussion on the floor with anyone willing to speak up, not more than 5 minutes per speaker. And if we have anyone willing to do that are not members of the dissertation council, they have to register in the ledger and also introduce themselves when they speak. Item 8, concluding remarks of the defendant of not than 5 minutes to address the questions, then presentation of the scientific advisor of not than 5 minutes. Number 10, deliberation for not more than 5 minutes before an open voting procedure. And then the broadcast, which is on the web, conducted on the website of St. Petersburg University, I switched off. 11, open voting procedure with everyone voicing their decision, and then a decision is taken to award or not to award a sought degree, and then a concluding statement of the defendant of not more than 2 minutes. The last 2 lines, please. Dear colleagues, have you got any questions or objections to this other work? No? Any objections? No questions, no objections. And then I will continue. Thank you. Before we carry out the other work, I would like to remind you that your mobile phones should be switched off. Thank you for your understanding. I would like to point out that that in audio and broadcast and video broadcast is carried out on the website. Simultaneous interpretation from Russian to English and back is being carried out as well. So I would like to start the agenda, and the first item is the paperwork that has been presented by the defendant. The dissertation of Petrov Alexander Nikolayevich, seeking the degree of the Doctor of Physical and Mathematical Sciences in Specialty 01.04.02, Theoretical Physics, on the topic Theoretical Research of diatomic molecules to search for dipole dipole moment of electron, has been accepted for defense. It was accepted for defense on the 7th of November 2019. The dissertation council was then established by the act of the academic secretary of St. Petersburg University on the 7th of November 2019, and well, the membership has already been introduced. The candidate has presented the following paperwork to the academic secretary of St. Petersburg. Personal application addressed to St. Petersburg University rector, Professor Nikolai Kropachev, to accept the dissertation for defense, dated on the 6th September 2019. Then a review of the academic consultant Anatoly Vladimirovich Titov, Doctor of Physical and Mathematical Sciences, and head of the Department of Perspective Research, St. Petersburg Institute of Nuclear Physics, the National Research Center, Kurchatov Institute, and then a list of publications consists of 30 titles, which cover the main scientific results of the dissertation, including in journals indexed in Web of Science and Scopus, 30 publications. Then degree certificate of the candidate of technical sciences, engineering sciences, dated on the 15th of September 2000, and then an expert opinion of the St. Petersburg Institute of Nuclear Physics, because this is where the dissertation was written. The dissertation was translated into English and is uploaded in English and in Russian and English on the website, and also printed as a hard copy. I would like to mention here that all the listed documents conform the requirements of Section 3 of the procedure of awarding academic degrees in St. Petersburg University. This is Appendix number 1 to the Act mentioned above. Any objections or questions? No questions, okay. Then Leonid Nikolayevich, this is your turn now. A short presentation. A short presentation of the defendant, candidate, of not than 20 minutes. Please, Alexander Nikolayevich. The dissertation is entitled is called The Theoretical Study of the Diatomic Molecules to Search for the Electric Dipole Moment of Electron. And the relevance of the purpose of this station is to develop a method and calculate systematic effects for the most relevant molecular system for searching for EDM, and other effects that violate P parity and T invariance. The search for new physics beyond the standard model of electromagnetic weak interactions, one of the main directions of research of physics fundamental interest. The reason is of the relevance of this is that the standard model predicts EDM at the level of 10 to the power of minus 38 ECM. While popular extensions of the standard model predict EDM at the level of 10 to the power of minus 26 to 10 to the power of minus 29, which is on the level of sensitivity of modern experiments. This slide shows the limitation of EDM obtained on different systems. The best limitation was obtained on the THO molecule. The accuracy of the HFF plus experiment is about an order of magnitude inferior. The experiments are ongoing. A further increase in accuracy is expected. Experiments are planned on other molecules, on lead, fluoride, and tungsten carbide, etc. And for what follows, we need a diagram of the level of diatomic molecule and how the interaction with the EDM does not affect. Let us consider an example of a molecule with omega equals 1 in the ground rotational state. Here's the M projection of the total momentum on the laboratory axis, the omega projection of the total momentum of the axis of the molecule. Levels with M equals 0 are not of interest for the experiment, and therefore are not shown in the figure. The experiment is carried in external uniform electric field. If we neglect the interaction with the EDM, there are two doubly degenerate levels with a you can call them star doublets with a complete polarization of the molecule. The four levels under consideration have different values of the quantum numbers of M and omega, which take values plus or minus 1. The degenerate degenerate general energy levels different in the sign of quantum numbers of both m and omega. In the future, Fulgaric with Alice with upper and lower doublets will be highlighted in red and green, respectively. In spectroscopy, they're called in D and F levels. The interaction of EDM leads to the removal of degeneracy, which should be detected in the experiment. Cleavage, very few. Less than a thousandth of hertz with a current restriction of an EDM. The splitting in proportional to the dipole moment of the electron of the so-called effective electric field. An effective electric field cannot be obtained experimentally, and this is one of the quantities that we need to obtain theoretically. In terms the Stray magnetic field, although this is not important, it's not the splitting of the levels that is measured and the angle of the precession of the moment of the molecule proportional to the splitting due to the cleavage caused of the EDM is very small. There are very many systematic effects that can simulate its presence, as shown in the thesis. Calculation of the spectra of molecules in external electric and magnetic fields make it possible to detect, understand, and find ways to express many systematic effects. Such calculations and the development of appropriate methods is one of the main objectives of the thesis. The main systematic effects are a change in the electric field, the presence of an unaccounted stray magnetic field, geometric phase, non-ideal laser polarization used in the experiment. Below, calculations of these effects will be considered on the slide. As an example, we consider stochastic effect associated with the magnetic field. A magnetic field, as well as an EDM, removes the degeneracy of the energies of Stark doublets. Therefore, insufficient control of the magnetic field leads to systematic effects in the experiment. Well, the key circumstance on the molecule with equal to unity is the fact that the structure of omega doublets is such that for one level, splitting caused by the EDM, the magnetic field add up. Then for the other, they are reduced. And therefore, if we take the splitting difference, the effect associated with the uncounted of magnetic field is suppressed, and the suppression will be the greater the small addition of the G factors of omega doublets. Therefore, it's clear that calculating of the G factors of omega doublets is an important task. The distinction found values of electric fields and stated for which the difference of G factors vanishes. Similarly, many other systematic effects are suppressed during the structure of omega doublets. And a large number of calculations of diatomic molecules performed in the adiabatic approximation. The full wave function is represented as the product of the electronic vibrational rotational functions, such as the approximation is also used in the work to calculate the effective electric field. However, to calculate the possible symmetric effects, it is necessary to take into account the mixing of the functions of the adiabatic approximation by external fields and due to the non-diabatic effects. And as pioneer calculations were performed in Zaitsevsky et al., to calculate wave functions and energies, the method of generalized relativistic potential was used. The method eliminates inactive external core electrons. On smooth spinors, valence properties such as dipole, magnetic, and angular momenta can be calculated with good accuracy. However, for properties such as effective electric field, hyperfine coupling constants, which are determined by electronic function in the region of the nucleus of the atom of a heavy element, it is necessary to restore the correct behavior of the four component spinors. And in this work, the non-variational recovery method was used for this, which was previously proposed by Peterhof. And in experiments, rotating magnetic at the HF plus rotating magnetic and electric fields are used. Two approaches were used to take into account the interaction with rotating fields. And this transition of a to rotating coordinate system was carried out. In the second, the interaction with the rotating fields were replaced by the corresponding quantized electromagnetic field. In the second approach, unlike the first, is applicable if there are static fields together with rotating arbitrarily directed ones. However, in the second approach, it is necessary to achieve convergence in the number of states and with different number of photons. The following slides then show the most important results obtained in this dissertation. This slide shows the calculation of the effective electric field. The values obtained from this work are highlighted in the blue. As I mentioned above, G-factor calculations are the most important. You can see that for the PBO molecule, the state of the sigma triplet is 1, taking into account the non-adiabatic interaction with the nearby state of the triplet sigma 0. The difference of G factors of omega doublets was obtained, which is in good agreement with the experiment. For the THO molecule, to calculate the G factors of the triplet delta 1 state on which the experiment to search for the EDM is carried out, the non-adiabatic interaction with triplet delta 2 and triplet state 0 was taken into account. Given the electronic configuration, these states have the greatest interaction with triplet delta 1. Metric element with triplet and 0 states were chosen to such a way as to reproduce the experimental value for omega doubling. The table shows this table shows the theoretical obtained in this work and experiment obtained by the ACME collaboration. The G factor vectors for the first three the rotational states in the absence of an external electric field. The results are published in a joint work. The values obtained without taking into account non-adiabatic interactions are highlighted in gray. And as we can see from the table, these values differ significantly for the experimental ones given in the last column. The penultimate column gives the theoretical values obtained with allowance for non-adiabatic effects. These values are in good agreement with the experiment. The values highlighted in the black correspond to the average G factors of omega doublets. Due to insufficient statistics, the individual values of G factors of omega doublets are not allowed in the experiment. However, theoretical values are obtained that can be considered reliable due to good agreement for the difference of G factors obtained in an external electric field. So this can be seen from the following. This can be seen for the following table. They calculated the experimental difference of G factors of omega doublets for the first three rotational levels of THO are given with a no zero external electric field. The experimental values of the difference of G factors are available to larger measurement statistics, since the EDM measurement experiments is carried out in an external electric field. For the HFF plus to calculate the G factors of the triplet delta 1 state on which the experimental research for the idiom is carried out, the non-adiabatic interaction for the triplet delta 2 and triplet 0 states were taken into account, and HFF is isoelectronic THO, and the choice of basis functions is therefore similar. The table shows the calculated values of the G factor of the ground rotational states of HFF plus in an external electric field. The values in the adiabatic approximation were calculated by Leonid Skripnikov. Non-adiabatic effects were taken into account in this work. The final value obtained is in good agreement with the experiment, with the exception of the sign of the G factor, which was corrected in subsequent experimental work. This table shows the difference of G factors obtained in this work in comparison with the experiment, given the large experimental error. Theory and experiment are in agreement. The calculation of difference of G factors in an electrostatic electric field actually corresponds to the calculation of the difference in the splitting levels of omega doublets in external static fields. A real experiment is carried out on rotating fields. It turned out that such a calculation of the difference of splitting in external fields is important for assessing the greatest systematic effect in an experiment on HFF plus. The experiment is conducted independent at different levels of the omega doublet. However, it seems that when the desired level is populated, a small population of the second is possible, which leads to systematic effects. Evaluation of this effect is reduced to a comparison of experimental and theoretical splitting levels of omega doublets, similar to the calculation in static fields. For the correct calculation of the splits, it is necessary to take into account non-adiabatic effects. When taken into account in this work, in red solid curve, in contrast to the previous calculations, correspond to the blue dotted curve. The agreement between theory and experiment circle is reached, which indicates the fact that the main systematic effect can be reduced, and indicates the further prospect of HFF plus. The rotation of the fields was taken into account in two ways, the result of which completely coincided. They developed methods as implemented in the form of program code that allows you to solve the universe problems, to find molecular constants, G factors from the experimental spectra on the molecule. Such a task was performed when processing the experimental data of the Zeeman effect in a PBFF molecule. After discovering the discrepancy between Skripnikov's calculations and of molecularly fixed G factors and previous experimental data, the experimental values obtained in this work are in good agreement with the calculations. Since an experiment to search for EDM occurs in an external magnetic field, it is important to know that the dependence of the G factors of omega doublets on the electric field, such a dependence of the ground rotational level of Peterhof is shown. Unfortunately, contrary to the initial expectation, the G factors do not become equal. The red and green curves do not intersect. This was experimentally discussed in 2004 and explained in 2009 by Kozlov. and the tendency of convergence can be detected in this slide, but then the grands fall apart. The G factor vectors would approach. It was expected, but would suppress the systematic effects associated with the for the unaccounted for magnetic field. In this work, we reproduced this result for PBO and obtained a similar graph for J equals 1 THO. For the same reasons, for the curves could diverge. We found and explained in this paper that if we consider the G equals 2 rotational state, then for it the nearest disturbing level will be a G equals 1 rotational state. As shown in this thesis, due to the opposite sign in the corresponding expressions of the perturbation theory, the action the perturbation will be opposite. We can, if the analytical denominator will be different. As you can see, the G factor of omega doublets for J equals 2 states are equal for a certain value of the electric field. For J equals 2, this value of the order of 50 volts per centimeter corresponds to the electric fields in which the experiment on the THO molecule is carried out. Such a situation can also occur for the main rotational state. Consider, for example, PGO molecule with lead isotope 207 having a spin of 1 second and therefore possessing an ultra-thin structure. The hyperfine interaction constant for the PBO 207 is negative, and therefore the level of the hyperfine structure F equals 1/2 lies above the level of 3/2. The hyperfine splitting is less than the distance between the rotational levels, so the main disturbance level for F equals 1/2 is F. The energy denominator will be negative, and the G factors of the omega doublets as functions of electric field intersect. And as calculations show, the intersection occurs at an electric field of about 10 volts per centimeter. Another important systematic effect is associated with the geometric phase of the Berry phase. And a static electric field, for example, in an experiment on a THO molecule can be considered constant only approximately due to the imperfection of the circuit boards creating an electric field. We can assume the existence of a rotating perpendicular component. Well, yes, we see that the experiment is carried out at different levels to suppress the different effects, and the leading order is cubic dependence, and this systematic effect will be much less than the current restriction of the ADM. These conditions, as we have seen, the possibility of conducting experiment to different levels of the omega double can significantly suppress many systematic effects. to further suppress systematic phase, other experimental condition change, and the precession angle is measured at all possible parameter values, only 8 combinations, and as thus it is a function of 3 discrete variables taking values plus minus 1. The function can be expanded in a series of these variables where there are the EF composition coefficients. Knowing the function as a result of measurements is easy to obtain expressions for the expression coefficients. The slide shows an example of an EF ENI. Similarly, others are calculated. It can be shown that the EDM is determined by the parameter EF ENI, or as they say in AI, with the correlated part of an EF, where tau is the time of precession. Let us now consider an important systematic and let us now consider an important systematic effect associated with the imperfection of the laser used to prepare the working state and read the EDM signal. As found in the experiment, a change and the Rabi transition frequency leads to a systematic error. The effect is explained in the link provided. The beta coefficient was measured in 10 and minus the third degree. And the similar to the angle of precession, the Rabi frequency can also be explained in a series of discrete variables and BE, since the EDM is determined by the EI correlated part of the angle of precession EF. The main danger for the experiment is an EI correlated part of the Rabi frequency. And the EN and EN end correlations of the Rabi frequency were experimentally discovered. EN correlation, it was explained by the change in laser power during the experiment at different levels of the omega doublet. You see this calculation. ENI correlation could be explained as shown in the thesis. Various correlations of the Rabi frequency can be associated not only with the experiment such the change in laser power, but also with internal disturbances. The figure shows the calculated EH correlation, which, as it turned out, coincides in order with the EH correlation from incomplete control to the laser power. For this correlation, analytical expressions are obtained that are in good agreement with numerical class calculations, and shows that this correlation is associated with the mixing of the neighboring rotation level, which equals 2. B and B correlations were found numerically. However, the correlation in I turned out to be compatible with 0. Here we get a certain problem, since this correlation could not be explained either by changing the laser power in the experiment or by internal perturbations in the molecule. However, in subsequent experiments, this correlation turned out to be compatible with 0, thus confirming the theoretical result. These theoretical calculations were used by the ACME collaboration to analyze systematic effects in the experiment. Another thing, that an extremely important quantity for experiments on the search of EDM cannot be obtained in an experiment, and this is one of the quantities that must be obtained theoretically. There's there's a problem how to determine the accuracy of its calculation. In addition to the analysis of conversions in the basic set, accounting for correlations, etc., a widely used method for comparing the experiment and theoretical values of the hyperfine coupling constants. And the hyperfine structure of molecules with the projection omega equals 1/2 is determined by two constants, A parallel and A perpendicular. A comparison of these with the experiment allows one to reliably determine the accuracy of calculating the effective electric field. And in a certain approximation, one can even obtain an analytical expression relating to the hyperfine coupling constants and the effective electric field. Fortunately for molecules with omega equals 1, which are currently more promising for the research of EDM, if we confine ourselves to the adiabatic approximation, the hyperfine interaction is determined by one constant, which complicates the analysis with the quality of calculation of the effective electric field. However, for omega equals 1 molecules that are promising for the search of EDM, the working state has a closely spaced electronic state with a similar electronic configuration. Taking into account the hyperfine interaction with the neighboring state allows introducing the additional constant, which will increase the reliability of determining the error in calculating the effective electric field. This slide shows the calculated hyperfine structure of PBO molecule. In the last column, the contribution from taking into account interactions with the neighboring electronic state is highlighted in blue. As can be seen, this contribution can be detected experimentally. This slide shows the calculated hyperfine the slide of other calculations shows the calculated hyperfine structure of a tungsten carbide molecule in the state of triplet 1 with and without taking into account the interaction with the neighboring electronic state of triplet 2. Similarly to the previous slide, the contribution from accounting for non-adiabatic interactions is shown in the last column and is highlighted in blue. The data show that the contribution can be detected experimentally for the molecules in question. In the session, a number of other calculations were carried out. For example, the PBF molecule, the hyperfine structure was obtained with a very high accuracy, and the transition energies, this slide could be approximated by standard effective Hamiltonian hyperfine interaction. And the distinction shown that approximating the spectrum within the experimental error, it is necessary to take into account centrifugal correlations of to the hyperfine coupling constants. And together with Flambaum, Stagnik, and Kozlov, the sensitivity of the spectrum of the PBF molecule to the various of the fundamental constants was calculated. The sensitivity of the components of the hyperfine structure of 177, 179 HFF plus to the interaction. The interaction is determined. Electrons with the magnetic quadrupole moment of the hafnium nucleus thesis statement to be defended. The method of calculating the hyperfine structure, the Stark and Zeeman effects include invariable fields, diatomic molecules containing heavy atoms. the value of the hyperfine structure contents, including centrifugal correlations to the ground electronic state pi 1/2, and the PBF molecule G factors in the body fixed coordinate system for the ground electronic state, two of the plumbum F molecule. This sensitivity coefficients in the transition frequency between the components of the hyperfine structure of the ground rotational state of the high plumbum F molecule to variance of the fundamental contents. The value of the EF in the molecules PBO HI plus PBF HFF plus dependence for the EF and for the HFF plus shaped and in external attaining electric and magnetic fields and the magnitude of the magnetic field. The possibility of improving the estimation of calculation quality of EF different molecules, so that you can see the previous slide, due to the incidence of perturbation of hyperfine structure of the state is shown. Correlation of the Rabi frequency of the transition H C in the thorium molecule with directions of external magnetic field and magnetic and electric fields, and I used components of the theta doublet of states HC, and analytical oppression to the correlation associated with the used component. Doublets is obtained, equality to 0 of correlation associated with the used component. The doublets in the direction of the electric fields which can lead to systematic effects on the EDM search experiment. And the cancellation of systematic phase associated with the geometric phase, presence of electrostatic electric field during the experiment on different components. The doublets in the rotational states affect the frequency of rotating electric field, and is shown for the ground J equals 1 rotational level. We have the Zeeman effects for the doublets of thorium molecules and external electromagnetic fields. Any questions, members of the Station Council? Members of the audience? Andrei Vladislavovich, please. What's the difference? Can you hear me? Sorry. What's the physical reason of the difference of G factors and F components? This is a non-adiabatic effect. So as 0, because the interaction with the others will be the same, and there will be J to 1 and J to equals 2 affects the situation. The most effect is 0 minus 0.6 for thorium O triplet. Well, there's no splitting between them. There's minus and plus, they were about the same. Well, this is the difficulty of calculation. The splitting is very negligible. If you look at this table, which is very, very small. You see the levels of J, E, and GF is the level of 10 to the power of -6. So the splitting is very small. but this calculated an experiment. Our calculations is also, it takes into account the effect of the rotational neighboring rotation state. You considered only one interaction, but there's another state that's a far-lying state. Yes, the effect is possible. Doubling of omega between the two states cannot be ab initio reproduced. As I said in my dissertation, the triplet Pino plus and minus, it allows us to understand the difference of G factors. I have a question. Thank you very much for this presentation. This is my question. You use very convenient the electric field notion. There's a critique of this field that it's not an electrical field, but this is not of much difficulty for us because there's a way to calculate this effective electric field. This is not an electric field on the electron, but the word effective saves the situation. Thank you. Any other questions? We talk about hyperfine interaction. 7%. Some calculations were conducted several years ago. We can calculate it better now. We add, in effect, an experiment. If we it happens often that, for example, here, two constants, A parallel, and that contribute mainly to the hyperfine splitting of the rotational states of the molecule WC or HAFF. We cannot calculate better than experimental people. We calculate 5 to 7%. The experimental. The experiment is this error. This correction can be calculated with more difficulty. And you see the difference E and F of PBO molecule. This was never obtained in experiment. As a parallel constant was calculated better in the experiment. So this combination allows to calculate systematic effects in a better way, more accurate way. Any other questions? No. Thank you, Alexander Nikolayevich. The next item, what is the next item on the agenda? And then now we're going to go to the reviews, including external reviews. The external review can be read first. Meeting Alexander Vasilyevich, Center Review, Doctor of Physical and Mathematical Science as the Moscow National Research Institute. This review and this dissertation was presented for the defense of the for the degree of Doctor of Physical and Mathematical Sciences. This is a relevant issue because this field is based on the achievement of atomic and molecular spectroscopy and the development of contemporary methods of quantum theory of the electron structure of molecules. The dissertation of Petrov Alexander Nikolayevich is dedicated to the development of theoretical methods necessary for the correct assessment of EDM and experimental works, and also non-empirical calculations of the electronic structure of diatomic molecules, diatomic molecules perspective, which is promising for the search of EDM, and the dissertation calculation method of hyperfine structure of the energy levels, effective electric field that acts on the electron in a molecule, the effect of Stark-Zeeman and Stark effect, including the variable fields for diatomic molecules that have the atom of heavy elements with the taking into account of non-adiabatic effects. The methods were used in non-empirical calculations of the molecule PBO, IHI, PVF, HF, and WC at theorem that are written, they described in the various chapters. The dissertation shows that based on non-empirical calculations of the first principle that the constants of the correspond to the centrifugal corrections for hyperfine interaction constants. Experiments with these molecules continue for the further increasing of accuracy in this experiment is necessary not only to collect body of statistical measurements, but also have the opportunity to suppress various systematic effects. The dissertation showed that the authors' research methods, calculation methods of molecules in outer external fields with perturbations accounted highlight the physical nature and allow the researcher to find a way to suppress many of them. The G factor shows the examples of the G factors show that the similarity of the properties of the level of the levels of the doublets sigma doublets play an important role in suppressing systematic effects in the search of EDM. It's very important. The dissertation has a very important effect. The result that it shows that the Rabi that with the use of the methods that was developed, the methods that were developed by Alexander Petrov, it was possible to analyze effects that are connected with the geometrical phase, and it is connected with the possible existence of a small rotating components of a laboratory electrical field, and non-ideal polarization that's of the THO lasers used in the experiment. In this dissertation, this is a very important result. Another, the results are reliable and verifiable. The dissertation, of course, has some drawbacks, but are very minor. Some typos. For the determination of G factors for different molecules, for example, PBO on the one hand and HFO and thorium on the other, don't coincide with each other. Possibly it would have been better to use one definition for all of the molecules, but on the whole, these criticisms don't diminish the positive evaluation of the dissertation and the dissertation of Alexander Petrov, theoretical search for the study of diatomic molecules for the search of electrical dipole moment of electron, conforms to the requirements of St. Petersburg University on the awarding of academic degrees, and the candidate, the author of the dissertation, Alexander Petrov, is with no doubt is entitled to a third degree of candidate of Doctor of Physical and Mathematical Sciences in Theoretical Physics. Well, PBO was just one molecule that the first molecule which was calculated with these methods. For these G factors, there was a dependence on the rotating effect of the quantum substance, and for the molecule 207, the Zeeman effect was calculated. We determined G factors in this way. They become equal, and you can see the influence of the change of G factors with spine or without spine. And this was done for convenience of calculating these effects with other external, to account for other external rotating effects. Well, there are a lot of studies on these molecules, and we use the commonly used definition in our work. Now I would like to turn to the members of the State Council for their reviews. And of course, let's start with me, because this is how the order of introductions went. So the dissertation was submitted for the degree, academic degree of Doctor of Physical and Mathematical Sciences. The dissertation of Petrov is dedicated to the development of methods of calculation of half refined structure of energy levels, effective electric field, working on an electron, the effects of Stark and Zeeman, and the corresponding calculations for a number of diatomic molecules, which and this is very relevant for the search of electrical dipole moment of electrons. Well, I will skip the description part. I will just say that this presents a test of the standard model for the and it's what we see there can be used for the verification of the current physical picture of the world, and this is one of the most promising objects for the search of EDM include polar diatomic molecules that include the atoms of heavy elements, and with the help of precision calculations of molecules, it's possible to understand and analyze a number of systematic effects in the experiment, find the most optimal levels of energy of molecules, of the molecule, and the optimal external fields for the experiment, and also calculation of effective electric field on the electron can be used for the calculation of observed shifts and splits of molecular levels to the value of the EDM that is observed in the experiment. And so these energy shifts that are generated by the EDM are very small. Because of that, for the analysis of the systematics, it is important and necessary to take into account various perturbations that are connected with the interaction between various electron and non-adiabatic effects and rotating states. And so the account of such perturbations is included in the proposed method of calculations, and that is presented in the dissertation, and it allowed not only to conduct high precision calculations, but to predict new effects. The calculations that in the experiment on molecule thorium-O, the preparation of initial state of molecule and the registration of the signal of the EM are conducted with the help of linear polarized lasers, and as was shown before, non-ideal polarization together with the incompletely controlled power of laser can lead to to systematic effects. The dissertation shows that for the first time it's unique that the internal perturbations in the molecule can lead to the same systematic effect as an incomplete control of the power of the lasers used. And this effect was used then by the collaboration of ACCME, which analyzed the systematic of Thorimo. The dissertation covers G factors of molecules in a great part of it. And the methods of there's also impairment. Also important that methods of calculating the specters of diatomic molecules and external fields are conducted in a software package, which program which allows the research to solve the inverse problem to find G factors of molecules by knowing Zeeman splits for the molecules be a Plumbum F, it became possible to obtain experimental values for G factors that had previously been obtained only with an error. And in terms of the Titov generated, but Titov, of course, is the consultant for the research work. Method of non-variational one center restoration in the correlation calculations. It was used and very reliable data was obtained for the effective electrical field, electric field EF in molecules Plumbum O Hi plus Plumbum F HF F plus, and the content of the dissertation find its reflection in 30 papers published in peer-reviewed journals, indexed in Web of Science and Scopus, and the work is very well structured, the illustrated, and the progression is very logical. There are some typos. Well, the formulas of quasi-energy. In terms of conceptual criticism, the name of the dissertation doesn't reflect fully its content. The electrical dipole momentum of electron is of course maybe the most important and the most debated embodiment of PT odd interactions, but you can. But PT, even neutral currents and magnetic quadruple momentum of nuclei are also discussed in the research work. in different chapters for the same values. Map symbols, different map symbols are used, and for example, in the chapter dedicated to thorium molecule, the doublet to the quantum value of n is used to refer to a doublet, to describe a doublet, but in the chapter dedicated to cation HFF plus, the quantum value of D, not quantum number of D, is used, but all the mentioned critical points don't diminish the positive impression of the distation, and the distation of Petrov Alexander Nikolayevich conforms to the main requirements set by the Act of 0109-2016 on the order of awarding academic degrees in St. Petersburg University, and the candidate Alexander Nikolaevich Petrov deserves to be awarded the sought degree of Doctor of Physical and Mathematical Sciences in Speciality 010402, Theoretical Physics. This was the first review, and next, maybe we should let the author of the dissertation sit down. Yes. So all the reviews should be read out, and then after that, okay. Now you have the right to. I would like to let the candidate sit down when a review is read. Alexander Nikolaevich, please. Dmitry Alexandrovich is right, and indeed other calculations are also carried out in the dissertations. A number of them noted in the remarks, as well as ADM violate spatial and temporal purity and theoretical study of molecules promising for the central. The main thing is the name does reflect the main content of the dissertation. As far as the quantum number, well, I'm just using the numbers. Experimental studies are carried by different experimental groups which use different designations for the components of and omega doublets in their publications, in the dissertation as well as in the publications of the author of the dissertation in periodicals. The corresponding notation is used. Perhaps the dissertation should have adhered to a unified system of notation, but this could make it difficult to compare the result of the dissertation with the results published by scientific groups. As far as the two approaches are used to take into account the interaction with rotating electric and magnetic fields. When working on a dissertation, such calculations were carried out. This slide shows the results of calculations of D and dB, correlated components of the precession frequency in the presence of both rotating and static electric and magnetic fields in one plane. In this situation, only the second approach is applicable. As non-zero value, the calculated frequency of FBD indicates the situation on only the second approach is applicable, and a non-zero value of the calculated frequency indicates the presence of a systematic error. However, if we had some non-accounted for static fields, then we would have a systematic error, while the electric, however, the possible value of the static electric field is estimated at the level of microvolts per centimeter, and therefore a possible systematic effect is not a problem at present, and these results were not included in the thesis. Thank you very much, Alexander Nikolayevich. I am satisfied with your answers. Then next review is from Professor Stelarov. I have a very positive review. I wouldn't like to read it out because it's boring and long. Our task is as reviewers to criticize, and I will do so, and then I will be able to commend. But the first thing I didn't like is the relevance, which cannot be confined to the calculation or the search for the dipole moment. The author is good at calculating the hyperfine structure of the molecule, and that's for every experiment, and the electric magnetic fields of included the count for the interaction between neighboring electronic states. These experiments are carried for super low temperatures, and spectroscopy is needed to obtain such molecules. The second thing, besides the the electronic the application also refers to high temperature experiments. What was done was not said. So then well, only a number of interactions are now accounted in calculations, but interaction with different omega states and different oscillation states are not accounted for, and I would like you to focus on this area in your further research. In terms of what would be good, well, this software package that was used, but unfortunately this software package was never described in anywhere in the dissertation, and this software package is a breakthrough, and if it exists, then it should be described. The first thing, another set of technical criticisms. Goals and objectives are not formulated in a good stylistic way. I address this drawback not to the author, but to the research consultant. Well, you should have looked through this and weed them out. I translated what I read from Russian into Russian, but whether I understood what was said is a mystery. And this work that a lot of works that the author draws on are quite that have some lacunes. For example, the works of the colleague with whom you've been working for several years are never cited, and it's very strange. Well, I just say that everything, the citation is in conformity with the requirements of St. Petersburg University on awarding the academic degrees. So the work that you mentioned, well, I actually mentioned it in my presentation, but I never saw it published in my presentation. I did mention it, but fortunately I couldn't cite it because I couldn't refer to it because I couldn't find it published. As far as the wider application, I agree with this remark. The developed methods and programs can be used in other areas. We can collaborate with the Stanford Technology Institute, NIST of the United States, and these methods were used, and actually they were used for ultra low temperatures. And Professor Profilov of St. Petersburg University runs a laboratory that specializes in calculating the dynamic polarizability of the hyperfine sublevels of the Kr-B molecule. As far as the oscillation structure, for example, study the spectrum of the iodine molecule in the laboratory. So if we these electron levels are too far apart, a few thousand centimeters apart, and these curves are very similar surface, and the same concerns triplet delta 1 and triplet delta triplet 2. We think that the Franken-Kohn effect is diagonal, then we see no output here. As far as the your formulations, I don't see that they are much different from my formulations, but I like them very much. I think that your work can be applicable to magnetic properties of hydrates, and because they're markers of the magnetic field. A very, very complicated structure where the G factor plays an important part, and there are experiments that are restricted to a field, and so your calculations would be very helpful there. I will continue the Moscow style, freer style. Well, I'm not going to read it. I will. A lot has been said already. We'll just have to put some accents. First thing I wanted this. So these high precision calculations can now be used for dipolar molecules. The application field is very wide, and to develop these methods is very important and relevant endeavor. As far as the dipolar momentum of electron, to go beyond the standard model, contemporary physicals, more experimental, you can work either on high energy accelerators, or look for hyperfine elements, properties of some objects, including diatomic molecules, where properties of matter are manifested where the standard model, which the standard model cannot take account of. Dipolar, no electronic accelerator can give the accuracy of the dipolar electric field as these theoretical calculations. So this is the only way, and the focus is in the decision on this is very correct. Large accelerators have economic constraints, and these hyperfine experiments that need a lot of preparation, of course. They don't have the same constraints. What was done in the dissertation is very carefully done. All the aspects of calculating dipolar electric field, it's very useful in all aspects, ranging from direct calculations of electrical fields to such subtle details as non-ideal surfaces which we saw on one of the slides. The theoretical of studied and masking effects and the analysis of interdependence, the experimental data is of crucial importance for the analysis and planning of future experiments. The optimization of theoretical approaches to analyze dipolar electric fields contributes to the study of molecules. I reformulated some of the results because I also found them hard to read. But irrespective of how they formulated, they are very important and significant, valid, and they create the ground for further development of the theory of diatomic molecules. Adding to Andrei Vladislavich, it's clear that the atomic molecules with the radioactive nucleus is a very important thing for nuclear medicine, where it's important to know chemical properties of molecules to know how it will gets built in the biological structure. The gamma transfer with optical energy has a very narrow width. It will be more accurate than cesium clock. The difficulty is that we don't know the energy of this transition, and knowing the molecules with the thorium atom can help, and I would like the author to pay attention to this area for further research. The dissertation is very good at validity. For every question, there's an attempt to go to the very end to substantiate, to justify, including using an experiment, etc. As far as the drawbacks, well, typos were mentioned already. There are two drawbacks. One is terminological. I am a representative of a different world, a nuclear world. But in our nuclear world, ab initio methods are termed the methods where nucleus Hamiltonian is included, and all the other nucleon and so on components are calculated from the beginning till the end, and we can go to the quark world, and this criticism can be addressed not to the author of the station, but to the community of nuclear physicists. Electrons are called a feed for us. This is a terminological comment. And the other one, maybe comical, and there's a story on page 80. You have an expression: the effects that violate the spatial and temporal odd even character. A representative of St. Petersburg community, staff member of the nuclear physics Petrov, doesn't know about the works of another colleague from St. Petersburg, of Petrov, Gennady Alexandrovich. This is very funny. In bound states, this effect doesn't exist. If T or odd is found, then the T invariant effect is obtained. T odd in division, the phases of splits violate T invariability, but it has nothing to do with the violation of the T invariability of Hamiltonian. And so now our standard phrase, all the drawbacks that have been highlighted don't diminish the value of the work analyzed, and I refer to 30 pages, to 30 articles in very respected journals, and I confirm that half of the nuclear physics people that use ab initio methods defend their distinctions in atomic physics and half in nuclear physics. Thank you very much for your comments about the terminology that you suggested for my future work. As far as what's T invariability and T odd, in our literature there's no difference really. If we talk about well, T invariant should have been maybe used, but T odd is used for variation. Bifurcation of the term has taken place, and therefore you're bound to use T invariant and T odd, two different phenomena. I will not read out my whole review, but I will just specify the precision methods of calculation of electric fields is including non-adiabatic effects are very relevant and lead to more accurate calculations. I would like to point out the relevance of the work that has to do with a lot of experimental data. That has to do with due to high precision of spectropic measurements. These experiments yield restrictions on the expansion of the standard model, which compete successfully with the results that are obtained in the physics of in high energy physics. In particular, the constraints on the value of a dm that's obtained in a series of experiments on thorium-O molecule in 2014 to 2018 practically closed the minimal models of supersymmetry, which had hitherto often regarded as the most probable candidates for the expansion of the standard model. And of course, today we need to expand to strengthen even the existing precision of the experiments and expand the experimental studies on other molecules, thorium F, palladium F, WC, etc., which requires reliable theoretical calculations on a new level of accuracy. And because the theoretical accuracy is very important, very worthy, the validity of the results of the dissertation work is confirmed by agreement with the theoretical calculations with the current experimental data, the agreement between numerical and analytical calculations, and the carrying out of calculations using different methods and program software codes that have been developed by the author of the dissertation. And of course, we see that the results of the work have been reported in Russian and international conferences, and even high-impact journal physical review letters. As far as the criticism are concerned, the dipole's hyperfine interaction of the is treated in the approximation of a 1-point magnetic difield, and it's known that for heavy atoms the effect of the diffusion, the dispersion of magnetic momentum on the nucleus, the Bohr-Weisskopf effect is very significant, and therefore it would have been great to dedicate some more time to this effect. As far as the this effect was not considered in the dissertation, but well, for the molecules considered in this dissertation, the main contribution to the hyperfine interaction contents is given by the valence of s and p orbitals of the atom of the heavy element. In this case, the Bohr-Weisskopf effect gives a correlation of 1 to 2%. The guaranteed accuracy of the calculation of the hyperfine coupling constants in this work is 5 to 7%, which exceeds the effect of Bohr-Weisskopf correction. My review is very positive. For me, it's an honor to be a reviewer of this station, because this work is of an international level, and I agree with all the positive points that we heard from my colleagues. To counterbalance the physics aspects, there's a term in English, scope. When it starts doing a project, making a project, you can there's a temptation to expand it to infinite levels, but I see it as good that this research is very concrete, and it addresses one of the most important issues of modern physics. This is the nature of the preservation of TP dipolar diatomic molecules are the main vehicle to address this issue. Well, the software was not described, but I think I agree with this. Which the author did and should have focused on the physics. A very good introduction, very clear language, scientific language, introduction to the issue and the main content of the dissertation, and the core of the dissertation, chapters 3 to 8, the specific features of results for a range of molecules, and current of potential experimental interest. The main thorium O and other experiment. HFF plus I'm dealing with, specialized in this. The ongoing instruments with just these molecules presently provide the most stringent limits of an ADM. And well, these experiments would not be studies would not be possible without the theoretical support of Mr. Petrov and his colleagues. As far as the drawbacks, some grammatical errors, some typos, and some tables, some figures, words are missing. Well, of course, when the volume of the document exceeds a certain limit, it cannot be devoid of misprints and so on. And I like the English translation, and concluding, I would like to say that the dissertation of Alexander Nikolayevich Petrov on the topic of theoretical study of diatomic molecules for the search of electrical dipole moment of electron completely conforms to the main requirements of the Act of St. Petersburg University on awarding academic degrees, and therefore Alexander Petrov deserves to be awarded an academic degree of physics and mathematics in specialty 010402 theoretical physics. And please, item 11 of this order is not violated. Thank you very much for your review. I will. There's no. This item is non-plagiarism item. As far as your question, in your question, in the errors of our calculations. Not for all calculated values an error analysis was possible. However, in a number of important cases, for example, when calculated the effective electric field, such an analysis done taking into account the experimentally known and calculate hyperfine coupling constant. These errors may seem quite conservative. But for example, for a PBO molecule, it is claimed that the real value lies between 90% and 130% of the calculated value. Note that the four molecules with a sigma equals 1, it was proposed to use data on the perturbation of the hyperfine structure to increase the reliability of estimating the error of the calculated effective electric field. This will require additional, more precise data on the hyperfine structure of molecules. I like the free style of our Moscow reviews, and I'm going to observe the same style. I'm not going to read my review. I will just say my opinion. I would like to highlight the fundamental importance of the results that are included in the dissertation by Alexander Petrov. We're talking about fundamental symmetry, about this symmetry as a reflection of time. There are three fundamental symmetries in nature: spatial and temporal invariability, and charge evenness. All theoretical physics account is based on these symmetries. All the equations of the classical and quantum physics, the theory of relativity, and deviations from these symmetries are known. In nature, all these symmetries are violated to a great degree. Well, in nature, the right and left are not symmetrical. It's also known baryonic symmetry is the absence or the minor presence of antimatter. And the inversion of time symmetry is totally broken. Well, for us, the progression of time is linear, and except the Strugatsky novel Monday Begins on Saturday. And there are interactions that are known between these symmetries and that try to explain these deviations of these symmetries. Well, we can talk about T-odd variables, but they were not in the focus of researchers. They have not been lately. 70 years ago, a dipolar moment, after Purcell and Ramsay published their work, the dipolar moment of an electron could be viewed by magnetic dissonance method. Well, photon, neutron, but photon cannot have a dipolar moment. After Ramsay and Purcell, experimental scientists have tried to find dipolar moment in any particles, but the effect of the electric dipolar moment is strengthened in heavy atoms, and even more in heavy diatomic molecules. This strengthening was a billion times, but the effect is so minor that it hasn't been detected. And the predictions of the standard model that even the best experiments fall behind the predictions by 9 orders. And and there's new physics that can make a contribution, but I don't believe in this new physics. Therefore, these experiments are so important. These experiments are record-breaking for dipolar moment of electron, and the American collaboration leads the way. ACME, ACME. These are very fine experiments, but these experiments are not direct ones. They need theoretical support of calculating this coefficient of strength of strengthening. So, as far as the calculations of such coefficients of magnitude that allow calculating heavy molecules, the laboratory of headed by Anatoly Titov in St. Petersburg Institute of Nuclear Physics, which has gone ahead of the competitors. Well, they are clear leaders. In a race that a horse outran his competitors by 3 or several body lengths, then you cannot compare it with the competitors. These calculations that are presented in the work relate to all the molecules that are significant for such experiments that I mentioned, for the experiments I mentioned. On thorium O, which the subject matter of the collaboration, but also for a wide range of candidate calculations, because in many laboratories in the world such experiments are being prepared because they're very important, because this issue is very important. And this group that I mentioned, Alexander is one of the leaders. That's why these works that he authors, that the works that he has authored are so important. In the dissertation, there are two introductory chapters that describes their method to calculate heavy molecules. In the second chapter, very important chapter, the author describes possible errors in the experiment, what effects should be accounted for, to be taken account of, to treat them as the emergence of a dipole electric field. Alexander Petrov noticed some inaccuracies in the conclusions of the experiment that relate to the results of the experiment, experiments of the American collaboration, and they have been acknowledged. This is what I wanted to say concerning this research work. Its fundamental significance for experimental physics. And I would like to read the formal parts of my review. What do I have to read? Let me read the dissertation of Petrov Alexander Nikolayevich on the topic. We already mentioned many times. Meets the main requirements set by the Act dated 01/09/2016. Well, number whatever, about the order of the procedure of awarding academic degrees at St. Petersburg University, and the candidate Petrov Alexander Nikolayevich deserves the awarding the degree of Doctor of Physical and Mathematical Sciences to be awarded to him. Clause 11 of this act has not been violated. This is the formal conclusion of my review. What else what do we need to do next? Well, then this is so next. Sorry, I'm not reading the right thing. What we do next? Alexander Nikolayevich, there haven't been any criticisms, but just a comment maybe. Thank you for your comments. Atoms and molecules. Leonid Nikolayevich is the founder of this research and in the research institute where I work, and therefore it's very pleasant to hear such remarks from him. So the research consultant Anatoly Vladimirovich Titov has there. I will just add that I will just follow the Moscow style. We have people from Novosibirsk to Moscow and St. Petersburg, three leading schools of physics and chemistry, and all the aspects of the dissertation council are covered. And we have comments that sometimes contradict themselves. But there was a critical about Alexander Nikolayevich is a third generation. Because the first works on EDM was started by Leonid Nakimovich Lazovsky, and then Novosibirsk school was initiated by Dr. Lazovsky, and he left us he was there. All these works became an impetus of the calculations of the second generation, Mikhail Kozlov and I, and the third generation are polishing and bringing all this this work to a good conclusion, and they are great followers. The critical analysis of such calculations. For an experiment, there must be data for heavy molecules. Pure ordinary Hamiltonians are not enough, and only and in order to construct the needed Hamiltonians, you have to use to build very accurate calculations. Well, the data that's had been accrued by the experiments that you mentioned were ameliorated by the calculations that were read in this research. So different aspects of well, there seem to be many. It looks like many disparate objectives were tackled in the dissertation, but in fact these are sub objectives of one objective, and they work towards the same goal. Well, Alexander Petrov has a chemical background, but he joined our group. He was very interested in physics, when I asked him why did you get a chemistry degree rather than a physics degree, and he said that in high school I didn't have a physics teacher, and therefore I didn't have enough training for higher education in physics. And I've tried to be a good advisor and made him redo the content of the work. Thank you very much, Anatol Vladimir. Are there any people who are not part of the dissertation council who are willing to speak up? No. All right, no. No one has registered. Thank you very much. Any other questions from the members of the dissertation council for the defendant? No. Therefore, we have reached the stage of deliberation of 5 minutes between ourselves, the members of the dissertation council, of the resolution to award the third degree. I would like, for the duration of these deliberations, to switch off the broadcast, and the guests and colleagues that are not part of the dissertation council. Please leave the room. I will invite you back in when the session continues. I'm sorry about this point. The session is continuing. And we have please switch on the broadcast and make sure that it's working. And this decisive moments of the decisive minutes of the Dissertation Council meeting are approaching. I am putting to the vote the resolution of awarding an academic degree I'm reminding you that the decision of the Dissertation Council on awarding the academic degree is considered legitimate or is positive if more than half or not fewer than 3 members of the Dissertation Council voted for it. According to item 23 of the order of awarding academic degrees in St. Petersburg University, appendix supplement number 1 to the Act. A member of the council, Dmitry Alexandrovich Telnov, your opinion. I am for the resolution. Member of the council, Andrei Vladislavovich Stolarov, your opinion, for it. Member of the council, Yuri Mikhailovich Chuvilsky, your opinion for it. Member of the board, Yerokin Vladimir Anatolovich, your opinion, I am for it. Member of the board, Dmitry Butker, your opinion, I'm for it. Thank you. I, the chairman of the council, Leontiy Nakimovich Lapsovsky, my opinion is in favor of the decision. So the votes are now being counted. Therefore, dear colleagues and guests, I declare that out of 6 participating members of the Dissertation Council, 6 persons voted in favor of the resolution. Nays 0 people, and abstentions 0 abstentions. Therefore, the decision to award an academic degree of Doctor of Physical and Mathematical Sciences in Speciality 01, 04, 02, Theoretical Physics, to Alexander Nikolayevich Petrov is taken. Therefore, congratulations and concluding statement. Thank you, all members of the dissertation. It's taken a lot of time for very close attention to the dissertation, good reading of the members of the Department of Quantum Physics for your collaboration, and for a scientific consultant for stimulating me to write. Natalia Vladimirovna for organizing the paperwork. Thank you very much. It was not so easy, but the session is officially closed. Thank you, everyone, Please switch off the live broadcast